Hello friends, welcome to my channel. In this video, I am going to discuss about equipotential surfaces. Okay, so what is equipotential surface? Equipotential surface, the name itself it is there, equipotential. That means what? It is a equal potential surface. That means in that potential, in that surface, electric potential value is to be same. All the point in that in that surface having same potential. So we can define the equipotential surface like this. Okay, it is a surface in which all the point have same potential. Okay, actually it is an imaginary surface. Okay, it is a surface in which all the points have same potential. Clear? Okay, then we have to see what is how an equipotential surface. Okay, so consider as a point charge. I am going to consider as a point charge. This is a plus Q charge. Okay, what is the potential produced by this point charge? Electric potential produced by this point charge is formula 1 by 4 pi epsilon naught Q divided by R. If I am going to consider this R is to be equal distance from here, so I am going to consider as a point here. Okay, that is how much distance I consider this is R distance. Another point I will going to consider here. Okay, so another point I will going to consider here. This is also R distance. This is also R distance. You see, this point, and this point I am going to consider. This all the point having what? The distance is equal. So this distance is equal. Potential produced by the point charge is to be equal. So if I will join all this point, what I will get? I will get a surface. Like this I will get it. Actually it is a spherical surface. Okay, so this is the equipotential surface of a point charges. So it is a two-dimensional surface. You have to consider it as a the diagram is to be two-dimensional, but you just consider it is not to be a two-dimension. It is a three-dimensional surface. You have to consider it as what? This surface, you consider the point charge is at the center of a sphere and the surface is like a sphere around it. Okay, you can see that the sphere around it. So this is the next one. Okay, so if I'll draw it here also, I'll get here. This is a equipotential surface. Clear? So these are all the this point, all these point having same potential because it is to be same distance from the point charge. Okay, clear. And one more thing we have to consider it. Here the distance between, here it is, this is the distance, here it is, this is the distance, here it is the distance. So you can see here while going away from it, the distance is to be increases. Distance between the equipotential surfaces increases. Why? Because while going away from this point charge, the electric field value will be decreases. So that we can say that the equipotential surface is to be, the distance between the equipotential surfaces increases. Clear? Okay, that is about it. That is about the equipotential surface produced by a point charges. Clear? Then we are going to study about some properties of equipotential surface. Clear? Properties. So here we have to see what is the shape of the equipotential surface. Concentric spherical equipotential surface. So point charges equipotential surface produced by a point charge is concentric spherical surface. Okay, these are the so concentric spherical. The distance between the spheres are to be increases. Clear? Okay, then we are going to study about properties of equipotential surface. Properties. So we are normally going to study about, there are three properties of equipotential surface. First property is work done to move a charge from one point to other point in an equipotential surface is zero. Work done to move a charge from one point to another point in an equipotential surface is zero. How it will be get, you will see this. Okay, so I am going to draw an equipotential surface. This is my equipotential surface. Okay, I am going to consider as a point. Here there is a point A, here there is a point B. These are the 2 points in this. Okay, clear? The distance between them is, how much is the distance between them? I am taken as dr is the distance between them. Okay, clear? If I need to move this q0 from here to here, I need to move it. Okay, so we are going to see about what? Work done to move a charge from one point to another point. What is the formula? Potential energy at final position, that is UB minus potential energy at initial position. Okay, this we can consider it as what? Potential into the charge, potential at B minus potential at A, Q0. From this, what you can take it? The Q0 you can take it as VB minus VA will comes. Okay, what about VA and VB? VA and VB are the point in an equipotential surface. So here you can say that VA is equal to VB. So if VA is equal to VB, what you can take it as? This value become 0. So what we will get this value? Work done to move a charge in an equipotential surface is 0. Okay, this is about that property. Then we are going to see about the next property. The second property is electric field at any point in an equipotential surface is normal to that surface. Electric field at any point in that equipotential surface, any point in that equipotential surface is normal to the surface. Okay, this is the second property. How it will be comes like this, we will see. So I am going to draw an equipotential surface. This is my equipotential surface. Clear? So what I am going to consider it the same like this. I am going to consider there is a 2 point in this. There is a point A and point B. I am going to consider it. Okay. So what is the distance between them? I am going to consider the distance between them is dr. Okay. So I am going to consider the work done to move a charge from here to here. Okay. So otherwise I am going to consider about work done to move a unit positive charge from here to here. I am going to consider it. Okay. So what about the potential A and potential B? A and B are the point in the equipotential surface. This is an equipotential surface. So I can say that VA is equal to VB is equal to what you will get? V itself you will get. Okay. So I am going to consider work done to move a unit positive charge from here to here. So work done to move a unit positive charge from A to B. What is the formula? Delta V is equal to what you will get? That is equal to, you will get it as E dot dr you will get. Okay. This formula already you know. How this formula came? I think you know already. We have to be discussed in the previous things. Okay. Work done to move a charge from one point to another. So here you can see that. What is the potential difference? Potential at final position. That is VB minus VA is equal to what? Modulus of E into modulus of dr into cos theta. If VA minus VB equal to what? 0, because it is equal. So if we need to get this thing, that means this value we have to get it as 0. What is the condition? If electric field is possible to be 0? No, it is not to be possible the electric field is to be 0. Then dr distance is 0? No. Then the only condition is the electric field is to be only condition to 0. Only condition to make this work done to 0, it is the theta become pi by 2. If the theta is pi by 2, what will get? The work done is to be 0. What is theta? Theta is the angle between electric field and dr. So I will be consider, I can draw this electric field at this point like this. Okay, so angle between this and this surface, it is making us 90 degree. Clear? So this is the second property. Clear? Okay. Then we are going to see about the third property. What is the third property means? Equipotential surface never intersect. Never intersect. How we can say that equipotential surface never intersect? So if it will be intersect, what will be happen? We will see. So I am going to consider as an equipotential surface. This is the one my one equipotential surface, and another one equipotential surface I am going to consider. This is the equipotential surface. I am assuming that these equipotential surfaces are intersecting here. Okay. So by considering here in the previous property what we studied, electric field at any point in this equipotential surface is perpendicular to it. So by considering this equipotential surface, I name it as A. So by considering the equipotential surface A, I will draw an electric field direction. You see this? This is the electric field direction I am going to draw. Okay. This equipotential surface I will name it as B. Why? By considering the B equipotential surface, I will draw a electric field perpendicular to this surface. So this is here. So from this what you can see that at a single point there are two directions of electric field is to be seen. So it is not to be possible at a point the electric field value is to be electric field direction of the electric field is in a single direction. So it is not possible to intersect two equipotential surfaces. These are all the properties of equipotential surface. Next we are going to see about there are different shapes of equipotential surface. Spherical, how the spherical equipotential surface will form. Cylindrical equipotential surface is there. How the plane equipotential surfaces are there. Then after that we are going to see about what is the equipotential surface of a dipole and what is the equipotential surface of a two positive charges are to be placed nearby it. So these are the things we are going to see.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like